We're going to continue with partial fractions, and it's going to be a little more complicated. But if you understood the premise in the first video, even though this is going to be a step up a little bit here, I think you'll understand. So let me jump through. So you have the PowerPoint slides for this, or the textbook. So we're going to work with some different ones. Let me show you what's different about this. First of all, in order to play this decomposing game here, we have to have the degree on the top is lower than the degree on the bottom. And if you look here, we do. If we FOILed this out, we'd have x to the third power would be our highest degree if you FOILed that. So we've got x to the third down here and x to the second on top. Okay, now here's what's different than in our last video. This is quadratic. It is not linear. The degree here is 2. Now, what you would first check is, well, why don't we just factor this down and make it like the last problems? Well, we could try, but this cannot be reduced. This is prime. So I can't factor this down, and it's going to make the trick slightly different. Let me show you what we're going to do. So what we're going to do, this is my first factor. It's a linear factor. It's going to be just like it was before. I'm just going to put the a over the x plus 3. Okay, that's simple. Now here's where things are different. We have a quadratic factor over here on the right. The top of this is going to be 1 degree less. So here we've just been having a single term. But now we're going to make this like a linear function. We're going to make this like a line. 1 degree less than the x squared, we're going to make it bx plus c. Do you see what we're doing? Degree 2. Now we're going to kick it down to degree 1 here. So this was quadratic. This is now going to be linear in our idle nose up here on the top. So the x plus 3 was just a normal linear factor, so we just make that a. Here we have x squared plus x plus 2. It is a quadratic factor, can't be reduced. So the top here, our idle nose, are going to be linear. They're going to be 1 degree less than what we were dealing with. So bx plus c, that's 1 degree less. Okay, now after that, it actually turns out to follow the exact same process. We're going to need an x plus 3 here. So if you give it to the bottom, you got to give it to the top. We're going to need, I don't have enough room for this, we're going to need an x squared plus x plus 2 over here. If you give it to the bottom, you got to give it to the top. Sorry. I know you can't read that, but this is the same premise. This guy needs the x squared plus x plus 2, so you give him to the top. He needs the x plus 3, so we give him to the top. Now, just like before, now they're doing a different approach. I like mine better. When we get here, what we've got is that we do not need to worry about the denominator, so it just becomes this. This is what we've done so far. Now, we're going to FOIL these out. With this one, all we got to do is distribute the a, and here we're going to have to FOIL this. So, here we are. This is just repeating what we already did. I think. What are they doing? Okay, so hold on 1 second. Okay, I don't really like their trick that they're doing here, so we're going to do this ourselves. So ignore this. What we're going to do, we're going to start with this line here. I'm going to distribute the a's. So I'm going to get ax squared plus ax plus 2a. Okay, now over here we're going to FOIL these out. So I'm going to get bx squared plus 3bx plus cx plus 3c. So all I've done is FOIL. Even though this is a b and a c and I don't know them, I can still FOIL this out. Now let's group together the right terms. So I've got a plus b and with the x squared. Do you see that? Now let's put our x terms together. I've got a, 3b, and c all in front of that all have x terms. Do you see I've got this one and these two? So all of those are in front of x. And lastly, what do I got here? I've got 2a and 3c. Okay, now all of this equals 8x squared plus 12x minus 20. So let's do the same thing we did before. So we're going to have an equation that says a plus b equals the 8. All right? And we've got a formula that says a plus 3b plus c equals 12. See what I'm doing? Just matching up the coefficients just like we did before. And then lastly, I've got 2a plus 3c equals negative 20. Okay, so now we've got some solving to do. Their trick is clever. I want to see if I can just do this without having to resort to it. So what I'm going to do here is I'm going to define a. Yeah, I'm going to say that a is 8 minus b. See what I've done? I've used this equation here to solve for a. Now, if the a is equal to 8 minus b, I'm going to put that into the other two equations, and then I will no longer have an a equation. It'll all be gone. So I've now got 8 minus b plus 3b plus c equals 12. And down here I've got 2 times 8 minus b plus 3c equals negative 20. Okay, now I'm going to tidy this up, and I'm definitely out of space. I'm going to try to go up here and keep going with this here. So what do I have here? I've got 8 plus 2b plus c is 12. And down here I've got 16 minus 2b plus 3c equals negative 20. Okay, I'm going to take these one further. I'm going to send the 8 to the other. So we're basically doing all of our old tricks for just solving a system of equations. It's one with 3 I don't knows. I'm just sending the 8 to the other side. Here I've got negative 2b plus 3c equals negative 36. Okay, now look what I've got now. The b's can line up. I could do elimination. Get that together. I'm going to get 4c equals negative 32. C is negative 8. Okay, so the dominoes should start to fall now. I've got C is negative 8. I could use any equation I want. I'm going to go back here. I'm totally out of space, and I'm sorry about that. But so I've got 2a plus 3 times negative 8 equals negative 20. So 2a minus 24 equals negative 20. 2a is going to be 4. A is 2. Okay, I've got another one. Now, I'm going to use that. I've got a plus b equals 8. So 2 plus b equals 8. B must be 6. All right, now I've got all my pieces. I've got A, I've got B, and I've got C. Now remember, this, if I have it, yeah, remember, this looked a little different. So we're going to write it here. I've got my A, but look what, this was bx plus C. So that's all we need. We've got all our values. Just remember it didn't look the same as it had been before. So 2 is our A, 6x minus 8. We have the same things, I hope. Yeah. So remember that was bx plus c. So that's how we decomposed it to look like this. Okay, let's try another one here. Again, pause it if you want to try this on your own. We can do this because we have a lower degree on the bottom. See, this is x to the second on the top. This would FOIL out to x to the third. Okay, and this cannot be factored. It's prime because of the plus in the middle. So that's stuck. So let's try to do this. We're going to do 5x squared minus 6x plus 7. That's going to be a. So this first term is linear, so we can just do this like we did before. Now the problem here is that this is quadratic and it cannot be reduced. So we've got x squared plus 1. So this is going to be bx plus c. That's what's new in this one. Okay, this term needs an x minus 1 added to the top and the bottom. This term needs an x squared plus 1 added to the top and the bottom. Okay, now the denominators match, so they're irrelevant here. So I'll come back to this in a minute. But so I've got a times x squared plus 1. Well, I better. So this is what I've got so far. Now, it still equals all of this stuff over there, but we don't need that yet. So we can disregard the bottom now. Now let's FOIL this out and distribute here. So I've got ax squared plus a. Now FOIL this out, I'd get bx squared minus bx plus cx minus c. I'm just foiling that. That's all that is. Here to here, here to there. I know it's got b's and c's, but it's no different. Okay, now that's been expanded. So let's combine things and then we'll worry about it. It really equals that 5x squared, but let's combine. So we've got a plus b x squared. Now, how about the x terms? I've got negative b, I'm going to write it like this, negative b plus c x, and then lastly a minus c. Now all of that equaled 5x squared minus 6x plus 7. So let's match up the coefficients. So a plus b must be equal to 5. Negative b plus c must be equal to negative 6. And a minus c must be equal to 7. Okay, now we could do this two ways. I'm looking for the easiest possible way. Yeah, here's the easiest. Well, it's going to be multiple steps no matter how I do it. I'm going to go ahead. You could do any step we want. You could do substitution like we did before, but I'm going to go ahead and do elimination with this process right here. If I add these two equations, what's going to be left is a minus b, the c's will drop out, are going to equal 1. You see, if I add these up, the a and b can't go together, but the c's will drop out. So I'll have a minus b equals 1. Now, if I put that together with the first equation and add these up, I'm going to be left with 2a equals 6, so a must be 3. Okay, so the dominoes are already going to fall because I have a as 3. Put this back into the first equation. You could do any equation you want. Put it back into this one here, and I've got 3 plus b equals 5. b is 2. Now I've got 2 of the 3. Let's use this bottom equation right here. I've got 3 minus c equals 7. Subtract that, so c is negative 4. Okay, so I have them. Now, all that's left is we have to write it based on the way we'd originally done it. To decompose this, it was 3 over x minus 1. And then it was b is 2, x minus 4 over x squared plus 1. So it's a little more challenging. We're creating this system of equations, but that's it. You have the skills. It's a little laborious, but you can do this. Okay, we've got one last one left. Yeah, here's the only thing that's going to be different. So once again, we have a repeated factor. This time it is quadratic, however. So let me show you what we're going to do here. Just to double check again, remember the top has to be lower than the bottom. This is, if you FOILed all this out, your highest you're going to get is x to the 5th. So this is going to work. This is lower degree on the top than the bottom. Now, look what we're going to do to decompose this with the repeat factor. So the x is fine. That's linear. We've been doing that all along. Super easy. Now, we have repeat quadratic factors. So we are going to follow the process that we did in the previous video. So if we had a repeat factor, we would do it once with degree of 1, an exponent of 1, and we would do it again with the degree of 2. Do you remember? This is the exact same idea that we had done previously. Okay, so now we're ready. Now we're going to play the same game. I don't know if I can... Yeah, let's jump. So do you see, this one's going to need an x squared plus 1, or it's going to need 2 of them. This one's going to need an x squared plus 1. It's going to need 2 of those. This guy's going to need an x plus 1, x squared plus 1. This guy's going to, and an x. This guy's just going to need an x. Okay, but doing the same thing. This is what this line is here. Just the same game we did to get the denominators the same so we can then ignore the denominators. Okay? Now, we're going to FOIL this out. We're going to have higher degrees here. So we're going to jump through this. This is super complicated. They're just foiling everything and combining. So we're going to get down to, this is that line where everything has been combined, just like we've been doing before. We just have much higher degrees. We're going all the way up to degree 4. So everything combines. We've got so many variables, it's getting a little overwhelming. But we now can generate our series of equations. So we generate this series of equations, but look how nice it is. We have some of them have already solved for themselves. I already know C, and I already know A. Well, if I already know A, I can find B. And if I already know C, I can find E. And do you see what I'm saying? I can put C in this equation, will allow me to find E. I can put A into this equation, it lets me find B. And then all that's left is D, but I have everything else. So basically, all the dominoes are going to instantly fall. And we've got all that we need. So Although the foiling it out and combining would have been very time consuming, the solving the system was quite easy. It's all there. It's all done for us. Now, let's just decompose it. So our original was A, which is 1. B, oh yeah, no, this was originally bx plus c, but b is 0, so that's going to drop out. So the c is 1. And then lastly, this was dx plus e. D is -1. E is -2. Yeah, just look what they've done here by putting it out front here. D was -1, so they had -1x minus 2. But if you make this here, it would go into both of them. Do you see they pulled out a GCF of a -1, basically, is how they got the minus there. And they've got it. It's all decomposed. Okay, let me see. Is this our last one? Okay, we're going to try this here. So they were a little bit merciful on us. First of all, we can do this because the degree here is to the 4th power, the degree on top is to the 3rd. So we're ready to go. Now we've got these are prime here. This cannot be reduced. And we've got a duplicate. So what we're going to do here is we're going to turn this into, to break it down, we're going to do, remember what we're going to do is the same concept that we did before, where we're going to do it to a degree 1 on the bottom. So we're going to do this factor 1 time. The top has to be 1 degree lower, so ax plus b. Now we're going to do cx plus e all over that same term, but this time to degree 2. Okay, so we're ready to go here. Yeah, now foiling this is going to be a monster. Oh no, actually, they were pretty nice to us. Okay, so this one is going to need x squared minus 2. He needs another one on the top and the bottom. Needs another one. So this will be all that we have to multiply out. This one had them both, so we're good. Does that make sense? This one is lacking in x squared minus 2x plus 3. This guy's got everything, thank goodness. Okay, so here's what we've got. I'm going to get some space here. This is the only thing we've got to worry about. Okay, now it all equals this side, but just this is so daunting, I'm just going to leave that off for a second. So we're foiling this through. I get ax to the 3rd minus 2ax squared plus 3ax. Now we'll send the b through. Plus bx squared minus 2bx plus 3b plus that's cx plus e. Okay, now as long as we group everything correctly, we'll be fine. There appears to only be the 1x to the 3rd term. Now how about the x squareds? We've got, I'm going to do it like this so it doesn't mess up the solving part of this. -2a plus b. Is that my only other x squared? It is. Now my x terms are going to be 3a minus 2b plus c. Those are my x terms. And lastly, no, not yet. Yeah, it is. I've also got 3b plus e. Okay, now I think I grouped all that correctly. And so let's match it up now with x to the 3rd minus 4x squared plus 9x minus 5. So let's match our coefficients. I already know a. A is 1. Do you see? That was easy. Now my next equation is -2a plus b is going to equal -4. I also have 3a minus 2b plus c equals 9. And 3b plus e is going to equal -5. Okay, now this looks bad, but I think it's going to be pretty easy because we already know a. So if a is 1, let's go to this equation right here. So I've got -2 times 1 plus b equals -4. So b is going to be -2 out of the other side. It's going to be b is -2. So I now have a, I now have b. So it's easy to find everything else actually. So let's go to this third equation. I know a is 1, b is -2, 3 plus 4 plus, okay, we've got 7 plus c is 9. C is going to be 2. All right, I've got 3 of them. And then lastly, go to this equation here. I've got 3 times negative 2 plus e is negative 5. So this is negative 6. Add it to the other side, it'd be positive 6, so e is going to be 1. Oh, sorry. Look what I did here. So this should have been a D. So it should have been A, B, C, and D. But using E didn't break anything. So you probably, if you did it with a D. Okay, now I have everything. So let's just decompose here. I have I have 1x minus 2 over x squared minus 2x plus 3. And I have 2x, sorry again, e, that's a little embarrassing. 2x plus, I don't know my alphabet. 2x plus 1 over x squared minus 2x plus 3 to the second. Okay, I know it's time consuming, but I think that the concept is exactly the same as in our first video. So hopefully, despite all of this, using your skills to solve systems of equations, you can handle this without too much trouble.